Excellent. So yeah, this is next-gen AV versus my shitty code, and in true former dev fashion, I stole all of this code from GitHub and various blog posts. I say my code, it's an amalgamation of other people's code. So who am I? My name's James. I'm a pen tester with Sakama. I do pen testing, red teaming, that sort of stuff. And I'm also a recovering .NET developer, so I did that for about 10 years before moving into InfoSec. So what's coming up? We're going to run through an explanation and theory of this sort of AV bypass technique. I've got a load of demos, a few bad memes, and then I've got the tool release on GitHub to send you all away with so you can all have a play with this stuff later on. So it probably helps if I run a demo first so you can sort of see what's going to happen later on in the talk. So if any of you saw the lightning talk version of this at SteelCon, this is one of the videos from that. But this is CYLANCE on 32-bit, and there's a reason it's 32-bit, which I'll cover later on. So run the video. So the window on the right is an RDP session into a Windows 10 machine running CYLANCE. This is CYLANCE in full block mode with PowerShell allowed. It's fully patched Windows 10. Windows Defender is on. If you can see what's going on, the tool I'm running in the command window is my stage for this product. So I'm passing in a crypto key and a URL to a payload server, which will be covered shortly. The terminal session that's behind the RDP is just terminal in my host machine. That's the text you can see there is the sort of old version of the payload gen, and then this is dropping interpreter shellcode into memory. So we've got the multi-handler running there. Run the command and we get a interpreter session open. So that's interpreter full established session, 32-bit, CYLANCE, the window on the side. It says inspecting because this was a fresh install, it's still doing the background scanning, but the active protection is running. So yeah, I pulled the host name out just so you can see there's no trickery going on there, but it is CYLANCE being bypassed on 32-bit. So that's what we're looking at here. So what just happened? The stage, which I'm calling updateservice.exe, just for a little bit of OPSEC, right? That fetched an AES encrypted payload, it built it in memory using Roslyn, then it executed it using reflection. The payload contained interpreter shellcode, which was injected into memory, and the stage checked it wasn't in a sandbox before it did any of this. So if you're in a sandbox, you can just exit out the process and do nothing. If that's difficult to understand, I drew you a nice paint diagram. Yeah, you can probably tell I'm not any sort of artist. This is the best I could do for you. So the payload server and the attacker machine, these can be two boxes. In all the demos, they're one box, but you can serve payloads from anywhere you want, and you can send shells anywhere you want. So the victim machine over on the right, it fetches the payload over the network after it's checked it's not in a sandbox. It says decode on here. It does decode. It also decrypts, so that this isn't me mixing terms up. It's a base 64 encoded AES encrypted payload. So it does that, it builds a payload, it executes it using Roslyn, it then does the reflective loading, shellcode's injected into memory, then you have the sort of normal MSF staging, so the back and forth between the shellcode and Metasploit, and then you get shells sent off to the attacker machine. So the real basics of this, it's written in C#, mostly because it's what I know, but you also get the benefits of reflection and stuff like that, which if people don't know, reflection is a way of launching something in memory in .NET. The payloads are fetched over the network, they go over HTTP. There's no reason why you can't use HTTPS for this, I've just not bothered to set it up for this. They are AES encrypted, so it's a one-time key, which we'll see in the payload generation stuff shortly. So even if you grab this off the wire without the key that's run on the victim machine, it's basically useless. The stage has to touch disk. This is a completely benign payload. It has nothing in there which should trigger any sort of AV product. If it ever gets signatured, you can just change the code, put garbage in there, do anything you want to change the signature of that binary. All that does is the fetch, build and execute. All the malicious stuff happens in what's fetched over the network. The cool thing with this, whilst the stage has to touch disk, the payload does not. So you can serve literally anything that is valid C# and have it built in memory and executed. So once you've dropped this stage on there, and I'm going to show you this in one of the later videos, you can keep reusing this tool to do new things. So you can spin up a Metasploit session, which gives you shell access. You can then use this tool to load other C# code into memory. So your first meme for the day, using C# to build C#. This is the Inception meme, if people don't know that one. So this is where the name of the tool comes from. So this is how we build C# in memory, and I'm going to stand here and wave the laser pointer around. So off the screen where you can't see, there's a bit of code that fetches the payload and does the AES decrypt. I'm not going to show you the code for AES decryption. It's pretty standard stuff. You're sending the IV along with the encrypted string and all the rest of it. If you Google how you do AES to work with Python and C#, you'll find the same blog post that I stole this chunk of code from. So the code variable at the top here, this is the plain text code. So first of all, we check we're not in SANDBOX, which I'll cover shortly. Then we fetch the payload, we decrypt it. If any of those steps fail, we just exit and return nothing. So we grab this code variable, we pass it into the C# syntax tree. This is the Roslyn way of sort of building code in memory. We need a random file name, so when you build stuff, you have to give it an assembly name, so we can just get a random name. It doesn't matter what that's called. And then this is the references block. So in the version that I'm releasing, there is another couple of lines in here. So if you want to bring in using statements in your payload, which aren't part of the standard .NET like auto-reference libraries, you can reference them here. If you don't do this, your payload won't build. You have to reference them for Roslyn to be able to say, okay, so I'm building this with this using statement. So you reference it here. I don't have the line in the slides that tells you how to do this, but it's in the code, so you can go and just drop in whatever libraries you need to bring in. Down here is where we do the compilation. So we use this .create, and we pass it the assembly name, the syntax tree, the references, and a couple of options of basically just saying spit out a dynamic link library, because that's what we're going to use at reflection. And then we emit the result of the build into a memory stream. So for those of you that don't know, a memory stream is basically a byte array in memory in C#. It's slightly more complicated than that, but that's all you really need to know to understand this. So once we've built this, again, slightly off the screen, there's an if statement that says if the build failed, return, do nothing, just drop everything out of memory, carry on as you were. In this else statement, this is where we do the reflective loading. So we grab the name. First of all, we move to the beginning of the memory stream just to sort of make sure we're building from the start of the app, otherwise things go terribly wrong. So this bit here, inception.program, is the namespace and the class that we're trying to build. So I'm going to show you the template for this shortly, but this bit and the run method, these are the only bits that have to match when you build your own payloads. So the namespace is inception, the class is called program, and your entry point into your payload is called run. And that's just a public static method. Any other code you want can be put in there, but it will call run, and your class has to implement this namespace. This is just the reflection way of loading stuff in memory, so it's pretty standard C#, like binding flags, invoke method, blah, blah, blah. And if we fail, we basically do nothing. This console write is in there for when I was building this and trying to do debugging. This should probably be taken out before it's sort of used in the wild, but there you go, it doesn't actually do anything. So that's it. Sandbox detection, this happens right at the start. So I'm using the check please scripts. These were released, I think, a couple of years ago at SteelCon. The GitHub link is there if anyone wants to have a look at those. Because I'm running this basically for debug and testing, I'm only doing 2 checks at the moment, so minimum number of USB drives and the minimum number of installed browsers. Nobody has ever used Windows 10 with just Edge. Like, nobody does that, so check there's another browser installed. Like, if you're doing that, you're probably safe from this tool at the minute, so, you know, brilliant, good for you. There are other checks you can do, so you can check you're on a domain-joined machine, you can check the domain name that you're joined to, so if you're in a Red Team gig and your domain in scope is acme.com, you can make sure this only executes on an acme.com domain. That's, you know, that's quite cool. It's really easy to add new ones in. You literally grab the code from the GitHub, copy and paste the checks you want, stick them in my code, and just make sure they're called. It's really simple to add new checks in. There's about 15 or 20 of these, I think, so loads of stuff you can play with. So the payloads, this is where it gets reasonably interesting. So this essentially executes arbitrary C# code in memory without touching disk. So anything you can do in C#, and C#'s kind of flavor of the month at the minute with Red Team guys, right? You can use this tool to load that into memory and bypass AV. So at the minute, I'm releasing, along with this, shellcode loader for 32 and 64-bit shellcode. Again, completely stolen code. This is not my code. Modified version of SHARPDUMP. So I've got a slide on this in a minute, but this is a set of tools released by SpectreOps. It basically does a memory dump of Alsace, and then you can extract creds using Mimikatz offline, which is kind of cool. But there are no real limitations on this. So when I did this at SteelCon, I said, There may be some issues of bringing in references to sort of use extra stuff in using statements. That's been solved by a few Google searches. So this is GHOSTPACK, where SHARPDUMP comes from. If you guys don't know about this, check out the link. It's an awesome set of tools. So it's basically a C# port of PowerSploit out minidump, and I've sort of modified it slightly to work with this tooling. I will show you the way I've modified that later on if we have time. It's not that interesting, to be fair. Okay, so the payload builder, this is a Python app. It's completely menu driven. I had to make a choice between command line switches and menus, and I'm still not sure I made the right choice. When you start getting into shellcode versions and template files, the command line switches are just getting a little bit unmanageable. So yeah, we have a nice sort of GUI menu that prompts you to make selections and put data in, and it spits out stuff for you. So this currently supports Meterpreter reverse HTTPS shellcode only. It is trivial to modify this to use any of the other output from MSF Venom. Literally all it does is call out on the shell to MSF Venom with some values you pass in. It gives you shellcode back, and you tidy it up to work in C#. It does find in a place, essentially. So your templates for shellcode have a tag in them, so angle bracket, shellcode, angle bracket, and it does find that template, take the shellcode, stick it in there, and then pass it on to be built and encrypted. We also support custom payloads, so these are arbitrary C#, whatever you want, it will just encrypt it and make it ready to be run by this tool. So the one I'm sort of releasing with this is the port of SHARPDUMP. There's other stuff that I want to port into this, but if you can write it in C#, you can load it this way. So this is just a quick video showing you the payload builder in action. I've recorded all my demos because live demos are just a recipe for disaster. So yeah, you get a video that I know is going to work. So this is building shellcode. You've got to have ASCII art in an exploit kit, right? So it prompts you to pick an option, so shellcode, custom, help, or quit. So you pick shellcode, it prompts you if you want 32-bit, 64-bit, and then it'll ask you for some variables for MSF Venom, so lhost, lport. The template file, these are just text files that you do find and replace stuff on, and then it calls out on the shell to MSF Venom, does the build and encrypt, and it spits out the crypto key up here. This becomes part of the URL that you pass into the stage that you drop on disk, and then the sort of generic one for custom templates. It does no find and replace, it does no building shellcode or anything like that. It literally just encrypts it and gives you a key and sticks it in a format where you can use it later on. So yeah, this is that in slightly more words. So shellcode payloads, it is using Meterpreter shellcode. There's no reason why you can't put your own shellcode in these. I don't currently support that. It would be a very trivial effort to add a new menu to allow you to do that. Or you can just make a custom payload with the shellcode in there, really easy. So if you want to pop calc on all your compromised machines, you can do that. It then writes the shellcode into the payload template, just using basic find and replace. It AES encrypts it with a randomly generated key, and then it writes two files. So in your home directory, when you set this up, it creates a .inception folder. Within there is a payloads directory and a payloads raw directory. Payloads contains the AES encrypted payload. This is used later on by the payload server. Payloads raw is there, so if you want to do any debugging on the stuff that comes out of this, you can access the template that it generated before it encrypted it for you. And we use the crypto key as part of the URL. So in the CYLANCE video, I was passing in the key and the URL separately. You no longer need to do that. It's the URL / the crypto key. Custom payloads is a little bit more straightforward. So we just do AES encrypt on the template that you give it. It writes the encrypted payload only. There's no reason to rewrite the raw payload in this case because there's no modification. Again, we use the key for the URL in the payload server. So if you want to build your own templates, this is how you do it. So this is just a really simple sort of empty class that you can fill in with your own data. So this is the bit I was saying is important. Namespace inception, class program, public static void run. So when you launch this and the code is built and executed on the compromised machine, this is the method that will get called. You can put any other methods in there you want, as long as it's valid C# and it builds. You can stick as many classes in there as you need to. This is the entry point, so call them from there, and then everything else will just sort of magically happen for you. So we also have a payload server. This handles the download requests from the stage. In the sort of previous version of this talk, it was just running on Python simple server. I've now built a proper Flask app, which allows you to do some other stuff. So at the minute, you can tell this tool the maximum number of times a payload can be read. It's defaulting to 1 at the minute, and again, there's not an option to set that, but the code is all there to do it. It's just a case of building a new menu. And it supports redirects if the payload is fetched more than n times. So let's say you're on a red team engagement, the client has a pretty good blue team, and you're worried they might be able to sort of fetch your AES encrypted payload. If they're monitoring command line, they have the URL and they have the crypto key, and they can pull the payload off the wire again by rerunning the request. So they have everything they need to decrypt that and find out what you've run on their compromised system, unless you just send them to something else. So you can send them to a legitimate looking update, or you can send them a completely benign file, or you can issue them a redirect to something else, which I have a video of this coming up. So this is a Flask app. It's got a SQLite DB backend, so the payload builder just drops crypto keys and links to files on disk into SQLite with a number of counts that are allowed. This reads that database and says, has this been accessed more than n times? No, okay, send the encrypted file. Yes, send a redirect. So if the sound works, apologies for the slightly potato quality on the sound. I don't have a way of recording screens. So this is the first request, and then the second request, and you can probably guess where this is going. There we go. Sorry, I had a chance to rickroll you all, and I went for it. So you can send these people, like you can send this to wherever you like. You can redirect to a different server, a YouTube video, whatever. This at the minute is hard coded in the server as a URL, but it's a trivial effort to sort of make that customizable. So for theory, that is essentially it. So I'm going to start running through the demos. I've got 4 or 5 different AV products with various videos. So again, I have recorded all these demos because the thought of doing live demos in front of this room terrifies me beyond belief. So the first one is SYMANTEC Endpoint 14, and this is their marketing blurb. It says, it is the world's most advanced single-agent endpoint security with prevention, detection and response, deception and adaptation. It's a lot of words. So let's sort of, is this? Yeah, cool. Let's see what happens when we run this. So again, same sort of setup, Windows 10 RDP'd into on the right. This is the new way of running the tool, just one command. You'll notice it says no check in there. I've disabled SANDBOX checks just to sort of run this in VM, because plugging in flash drives and installing stuff is a bit of a pain. So we can run, we've straight away got a Interpreter shellback. This is 64-bit now, full 64-bit, fully established Interpreter session. It saw nothing, it did nothing, it has some fancy words, but it just don't care. Cool. So the next one, SOPHOS INTERCEPTX. I should probably say that all these products, they get more and more next-gen as we go. They all claim to be next-gen, except ESET. ESET have a blog post where they say, we don't believe in next-gen, we've been doing this a long time, we do the same stuff, right? So this is SOPHOS INTERCEPTX, their strapline being, seeing the future is the future of cybersecurity. So you can probably guess what's going to happen with this one by now, right? But so this again, full patch Windows 10, Defender is on, latest definitions and all the rest of it in SOPHOS. So we'll run the same thing, and again, Interpreter session. It says 25 in here. I did a lot of testing when I recorded this video, so so yeah, full 64-bit Interpreter session. So that's that one. So this, I wanted to sort of show you can do things with this session. It doesn't signature on stuff once you have the session. So the terminal window on the left is me running Mimikatz via Interpreter. So you have Interpreter, you can still use all the cool tools that you can run in Interpreter. So you can do creds all, you can load Mimikatz, you can dump hashes. There's no hashes in there because I've not turned on the reg key in Windows 10 to say store them in plain text, but it still executes, it doesn't signature on anything. It has, so this is interesting with SOPHOS. I don't know if you can read this, but it warns the fact that I've run an unsigned binary on this host. It didn't block me running it, but it has sort of logged it that I've executed an unsigned binary. So what, I guess? It's not really done a great deal apart from like saying I've done it. By the point I've done it, it's too late. So ESET, I've not got the blurb from the blog, but if you go and have a Google around about ESET and NextGen, they have a very wordy blog post saying, we've been in this industry from day one, we do all this stuff that people are now calling NextGen, like we don't believe in it, all this kind of thing. Getting a trial for their business offerings is actually kind of difficult, so you can only really get trials of the home user offerings, but they do basically the same stuff. If you look at the tick list of what they all offer the same thing. The home version just doesn't have the sort of management interface and all that kind of stuff. So the demo is going to be with ESET Internet Security because of this line here, which says it blocks attacks specifically designed to evade antivirus detection. Yeah, so that's a bold claim, but I am pretty much taking this as a challenge. Yeah, like the more I read in the marketing blurb, the more I yeah. But yeah, so this just again does not care that you've just launched Meterpreter SHELLCODE. The reason I chose Meterpreter SHELLCODE for this is because I kind of wanted these things to signature on it. I wanted to give them every chance of flagging this tool. So if you try and run Meterpreter, just like spit out an exe from MSF Venom and drop it on any of these hosts, they flag instantly. You can't get it on disk. It's instantly detected. So this is using the XOR, whatever the E-flag XOR for shellcode in MSF Venom is. The 32-bit is using the Naga encoding, but they're still signatured. You can still drop these files on disk and they'll get detected straight away. So ESET allows you to run Meterpreter. If you try and drop into shell for Meterpreter on ESET, it has a little bit of a moan about that. So this is it's established 64-bit Meterpreter session. I've run this as admin. So we can get system, we can elevate to system using name pipe in memory. Drop it to shell and it doesn't work, which is unusual, but try it again. And then it flags the fact that you've dropped into command shell from Meterpreter. So, what the fuck? So, to recap what we've done here, we've run an unsigned binary, doesn't care. We've downloaded some random stuff from the internet, doesn't care. Built it, executed it, launched known bad shellcode in memory, established a full Meterpreter session. It doesn't care about any of that. You can go on and you can run mimikatz, you can dump hashes, you can do all the cool stuff Meterpreter can do. But you can't have access to the system shell because that's going to stop the bad guys, right? I have no idea why it flags on this. It seems completely bizarre, but there we go. So MCAFEE, yeah, this is another one. Outmaneuver attacks through advanced consolidated endpoint defense. The interesting bit in here in the blurb is this near real-time detection. Where are we? Detect zero-day threats in near real time. I don't know what the definition of near is, but you can probably guess what's going to happen. So this is an old video. I ran this at SteelCon. So this is when you install CYLANCE, it actually kills VirtualBox because it does DLL injection, and VirtualBox doesn't like that. So this was before I installed CYLANCE on this Win 10 machine, so this is running it. Yeah, it's the latest updates. Older version of the tool, but still the same technique. This is just, rather than sending a shell from a VM to from RDP into a host machine, this is just sending it into a virtual machine. It does the same thing. This one doesn't mind if you go into the shell. Yeah, so in most of these, I'm dumping out the host name just so you can sort of see there's no trickery going on. But if you can't read it, trust me, there is no trickery in these videos. So that is MCAFEE. And then we come to the good one. So all the other products here are sort of home user, business user offerings. And they all claim to be next gen, but they're all long established companies, right? They've kind of moved into the next gen market because that's where things are going with AV. SentinelOne is a reasonably new company. They don't offer anything other than next gen, as far as I can tell. They have bold claims in their marketing taglines, as does everyone else. So that, yeah, this claims to defend every endpoint against every type of attack at every stage in the threat lifecycle. So before I run the video, the trial for this, you can't get one from SentinelOne directly. I managed to get one through a slightly shady-looking South African company who resells this on their behalf. Interestingly, I'm fairly sure that company has an XSS on their login page for the management portal. Speak to Bob later and he'll be able to tell you about that. So when you first install this, it didn't flag anything, ran the tool, didn't catch anything. I thought, this is brilliant, this is going to be an awesome video. And then I started thinking perhaps this is slightly too easy. So I dumped out an exe from MSF Venom, dropped it on desktop, didn't detect it, executed it, instant shells, didn't detect it. It's like there's something not right about that. So I left this running on the VM for a couple of days, thinking maybe it needs to sync with a server, download some sort of definition file or something like that. And then after 2 days, it did actually detect Metasploit as an exe. So if you install this and expect it to protect you from day one, it won't do that. I don't know why, but it took at least 2 days of sitting there.
It did say near real time, though.
It did not say near real time, like, maybe it should have. So this is Sentinel-1, same sort of thing. I've got a couple of videos for this one because I expect better from the product with this sort of reputation. So this is you can probably tell what's going to happen by this point in the talk, right? No threats detected, it's monitoring 98 processes, 91 services. We still got a interpreter session out of it. So yeah, we can full 64-bit shellcode, we can interact with it, we can do all that kind of stuff. We can drop it to shell, it doesn't care about that, unlike SOPHOS or ESET, whichever one it was. Yeah. So, yeah, pull the host name out for you. Yeah, it is running on this host. So, what if I told you this gets worse? So, this is a next-gen product that claims to prevent every kind of attack, right? So, getting a shell on a box, we've seen this with CYLANCE, which I'm going to cover a little bit in a minute. Just because I have a shell on this box doesn't mean I can actually do anything useful with it, apart from use it as a pivot point, if you're sort of blocking other stuff. So this is the video of the full sort of end-to-end of this tool. So we're going to start off getting a interpreter session, as we have done in all the others. So you generate it using the nice little menu structure here. The template path is the path to the text file you want to replace shellcode with. And it will call out and generate that for you. Yeah, apologies, this is a 2-minute long video because I don't know how to speed these up when you record them. Oh. Yeah, we'll do the same thing, pass it the URL. So this is, if you can read that, this is how you call this tool. You just literally give it a URL. Over here we should have a Metasploit session come in. There we go. So now we've got an established interpreter session. What we probably want to do at this point is start trying to dump creds from this host. Let's assume this is a domain controller or a host that like domain admin's logged in on or something like that. We can run this tool again from our shell session and launch other C# code. So this is where you're going to see the port of SHARPDUMP. So you go back into the payload server and the payload builder and just build the SHARPDUMP payload. So this is a custom payload. It doesn't do a great deal apart from encrypting it. So we need the crypto key. And then we can just run this directly from the Metasploit session. You get to watch me type in real time, which is, I'm sure you all wanted to sit and see that. There we go. So this now is going to go, it's made the request to go and grab the payload. It's going to start dumping memory from LSAS. This takes a little bit of time to run. This system isn't, it's a brand new VM, basically. There's only one user on there. There's not a whole lot going on. The interesting thing with this is it does kind of hang the shell a little bit. I've got no idea why. It's in a new process. It shouldn't have any sort of impact on the Metasploit session, but like when you run dir in a minute, it sort of lags a little bit while it waits for it to sort of finish dumping memory, which is this. So what this is doing in the background is doing a memory dump of LSAS, and then it's turning it into a gzip file, renaming it with a .bin extension. And you can exfiltrate that to your local system. You can run Mimikatz on that memory dump. As long as it's the same version and architecture of Windows 10, you can just run Mimikatz against a memory dump rather than doing it sort of on the compromised machine. There we go, that's finished. So if we run dir-bin, the first one is me testing this. So the debug, so 864, the 864 is the process ID of LSAS in this instance. So the second one is the one that we've just run. So we can go and download that file. Yeah, this is me failing at remembering where I am in the file system. So what I'm not going to show you is actually dumping the credentials, because once you've got the memory dump, it's reasonably straightforward to just run Mimikatz. It doesn't really add much value to this, but so we can go and download this memory dump. So to summarize what's just happened, we've run an unsigned binary, we've launched shellcode, we've got an established Metasploit session, we've dropped it to shell, we've run this unsigned binary again. We've then launched a process that is dumping the LSAS process memory. So LSAS is a privileged process, right? You have to be system to read this memory. So we've moved up to system, we've started dumping memory. It's succeeded, it's created a whopping big file on disk, and then we've downloaded a whopping big file. Sentinel-1 doesn't care about any of these actions at all. This whole prevents every type of threat. I mean, you can kind of draw your own conclusions from that, but it's not prevented this one. So CYLANCE. So when I did this at SteelCon, I'd only actually built the 32-bit version of the shellcode launcher, and it worked perfectly well. We saw the video at the start. You can get a shell with 32-bit on CYLANCE. It doesn't care that you're doing all this stuff. But it's not quite as simple as that. So when I built the 64-bit version of this tool, tried it on CYLANCE straight away, and it blocks everything instantly. It's not like... So it turns out it actually flags on marking memory as executable. So when you run 32-bit shellcode, it's slightly different to running 64-bit. To run 64-bit, you allocate memory and you mark it as executable. Marking as executable causes CYLANCE to flag that process and kill it. It doesn't kill the exe that you've uploaded, because this happens in a separate process, but it does kill that process. So you can't get a 64-bit shell via shellcode. It also flags on LSAS read. So you can still run the SHARPDUMP directly. You don't need a shell to do that. And it will start running and it will generate an output file, but the content is absolute garbage because CYLANCE stops it from reading LSAS. All this 64-bit stuff that is nice to do, CYLANCE will flag on all of it, as far as I can tell. But it completely ignores 32-bit. Like 32-bit just doesn't exist to CYLANCE, so it does prevent you getting a nice Metasploit session, and it prevents you dropping credentials and all the rest of it, but I can still use that host as a pivot point. I can still have shells on that box, and you can kill CYLANCE if you have shell access to the box. Like, it's not part of this talk, but there are techniques to kill CYLANCE once you have sort of system access on that box. In the 32-bit shell, you can elevate to system using in-memory, whatever else you want to do. CYLANCE doesn't care. So if you try and run this in 64-bit, it's not going to work. But if you happen to have a way of killing CYLANCE, then you can still get shells, you can kill CYLANCE, you can migrate into a 64-bit process, get a full 64-bit session, and you're still winning. So that is it for the demos. Further work on this, I've done a lot of the stuff that I was talking about at SteelCon. The next thing I want to do is add postback support to that payload server. So at the minute, it's GET only. If we could allow it to receive files or output from commands, that opens up a whole new world of payloads that we can do. So dumping a file on disk, for example, we could just exfiltrate that straight back to C2. You just post it as a file. More templates. I've said a few times, sky is the limit with this. If you can write it in C#, you can run it using this tool, and it will bypass AV. So CYLANCE is flagging on shellcode execution, but you can build diverse shells in C#. There's no reason why you can't do that. Test it on more AV engines. The ones I've tested on are the ones I've found with the biggest sort of market name that claim to be next-gen or justify why they're not next-gen. Carbon Black, CrowdStrike, those sorts of things. Trying to get trials for those is basically impossible. I've sent a couple of requests off and been ignored, or had a sales guy asking me how many hosts I want to install this on and trying to sell me a 500 user license. I'm not buying a 500 user license to test one tool for 5 minutes. And porting this to other languages. So I stood in front of SteelCon and said this would be awesome to write in Java. Java can do the same sort of thing of building itself in memory. So one of our guys wrote this. The Java implementation, written by Paul Ritchie, who's our sort of head of all things Scotland. He presented this at DEF CON in Glasgow. If you want to play with it, it doesn't do shellcode, but it does all the sort of building Java in memory. So that's his GitHub. It's an awesome tool. So how do we protect against this? Well, this is a post-exploitation tool, right? So avoid the initial compromise. Probably easier said than done. So what I'm not releasing here is LEO days in AV. None of this code targets AV in any way. It's just a way of bypassing it. There will always be AV bypasses. This is not a new thing. It's not going to be the last of them. So don't rely on AV. Like, AV is brilliant for stopping stuff like crypto locker or like known malware samples. But there will always be like patient zero. You always have to have somebody who got wrecked by something before there's signatures for it. So do your defense in depth. Put alerting on stuff. Everything I've shown you, if you have decent alerting, you should have at least detected that host being compromised, like suspicious network traffic, unsigned binaries being ran, huge files being exfiltrated across the network. Alert on all of it and send the blue team guy out to figure out what the hell's going on with that server with smoke coming out of it. So yeah, there's no real way. So I've not approached any of the AV vendors with this, by the way. It's not an exploit for AV. If I told one, I'd have to tell them all, and there's nothing really there that needs to be disclosed. This is just a technique that, whilst they should be flagging on suspicious actions, like CYLANCE, for example, in 64-bit, does quite a good job. It prevents you doing things that, like, attackers will do. The others don't. This isn't going to get patched by AV. You're going to have to put the defense in depth stuff in place. So the moment you've all been waiting for, I'm sure, the tool is live on GitHub. It has been there for a couple of weeks. It's stable. It's been used in the wild on some of our engagements. There's feel free to take photos. The slides will be stuck on GitHub later on this week, probably tomorrow when I get home. I'll drop some of the videos on there as well if you want to watch them again. You've got the 32-bit shellcode launcher, 64-bit shellcode launcher, the port of SHARPDUMP. The README's got the template in to build your own payloads. Enough info to get you going with it. It's all there. You need a couple of dependencies just to make the font colors nice and stuff like that in the payload builder. So that's it. You can go away and start using this now if you want to. Well, that's it. If you've got any questions, shout them out or come find me on our stand outside and grab me on Twitter. Shout them out if you're gone.
That's it. Give it up for James. Thank you. Has anyone got any questions? If you do, I've got the mic. If not, yep, Dom.
Yeah, just a quick question. Have you ever actually checked or verified that the compilation happens purely in memory?
Yeah.
So, I don't know if you've used code DOM, for example. There's certain compiler parameters that you set, generate in memory equals true, but they actually lie. So they usually drop the C# source code to the temporary directory, then call out CSC, load the DLL, then import the DLL into memory.
So I've not monitored every action that's going on with this.
So that's how the other C# in memory compilers work in .NET.
Yeah, it's worth looking at. I know the sort of .NET way. So there's a few different ways of building .NET, right? You've got MS Build and the other one that Visual Studio uses. Those definitely touch disk.
So I think most of the things
Okay. Well, I'll have to take a look. It's one thing I've not looked at, but I guess it kind of doesn't matter at this point.
But the C# source code can touch disk, so the signature
Interesting. Yeah. I'll have to have a look. If you've got a link to your blog, fire it over on Twitter. I can run do it tomorrow, find out if it actually touches disk or not. I was under the impression it didn't. I've not seen any evidence that it does, but if you're saying it's calling out to something I didn't know about, then yeah, it may well do. Yeah, awesome. So I'm going to change the slides and say it may touch disk.
Excellent. Anyone got any more questions? If not, we've got the Visa tweet king of the internet, Chris Boyd, in here next. There's a coffee break at 11 o'clock. So, see you guys in a bit. Thanks a lot.